Hey y'all, welcome to your Unit 10 test review video. This video is going to be numbers 1 through 8. There will be another video for the rest of the review. First of all, note your test dates. And let's start looking at some of these problems. Before we do, let's review just a couple things. On the XY axis, quadrants 1 and 2, trig functions inverses that have principal values in quadrants 1 and 2 are cosine inverse, secant inverse, and cotangent inverse. Those are in quadrants 1 and 2. Then the trig inverse functions that have principal values in quadrants 1 and 4 are the others. Those are going to be sine inverse, cosecant inverse, and tangent inverse. And remember, quadrant 1 is always for a positive ratio, and quadrant 2 or quadrant 4, depending on your function, is for a negative ratio. And one more quick thing, remember in quadrant 4, we use negative angle measures. That's one of those things that's the way it was decided it was done, and so it is. Okay, so in 1 through 4, we are finding the exact principal values in radians. So tangent inverse of 1 will equal something. That 1, because it's inside an inverse, is a ratio. We are finding its angle. So we're finding the angle where tangent is equal to 1. Remember that tangent's ratio is y over x, so that's 1 over 1. Also remember that tangent inverse has principal values in quadrants 1 and 4. Because this is a positive ratio, it will be quadrant 1. Positive ratios will always be in quadrant 1 for principal inverse values. So if x and y are both 1, what that means is that the legs are the same. And so that automatically gives us our 45, 45, 90 triangle. So on the coordinate plane, in quadrant 1, drawing our triangle perpendicular to the x-axis, one leg sitting on the x-axis, theta at the vertex at 0, 0. We already know that this reference angle is 45 degrees, which in radians is pi over 4. So this angle is pi over 4. Pi over 4 radians, it's 45 degrees. It's in quadrant 1, so it is its own reference angle. Let's look at number 2. We have sine inverse of 1 over square root 2 with a negative sign on it. That negative 1 over square root 2 is a ratio, meaning we are looking for the answer that will be the angle. And sine inverse can be in either quadrant 1 or 4. So being a negative ratio, this will be in quadrant 4. Drawing into quadrant 4, perpendicular to the x-axis, one leg sitting on the x-axis, theta at the vertex at 0, 0. Now, if we look at sine, we know that sine is y over 1, which would be negative 1 over square root 2. Okay, we don't leave that square root 2 in a denominator, so we will multiply by root 2 over root 2, and that will give us negative square root 2 over a 2. And that's a very familiar number for a side of a triangle. That y is negative root 2 over 2. That means x is root 2 over 2, and that hypotenuse is 1. With the legs being the same, that is a 30, 60, 90 right triangle. Sorry, this is a 45, 45, 90 triangle. So that reference angle is 45 degrees, which is pi over 4. Now, in quadrant 4, we use the negative angles. So this angle, this angle is negative pi over 4. It's pi over 4 units below 0, so it's negative pi over 4. It has a positive equivalent, but for principal values in quadrant 4, we use the negative angles. Let's look at number 3. We have sine inverse of -1, and that will equal something. That -1 is inside an inverse. That makes it a ratio. So the answer we are finding is its angle. Sine inverse can be in quadrants 1 or 4 for its principal value. With a negative, we're looking at quadrant 4. Sine is y. So that y would be equal to -1. The only way for y, a side, not a hypotenuse, to be equal to -1 is if the angle is on an axis. So where y is equal to -1 would be straight down. The coordinates of that point would be 0, -1. I don't know why that was there. 0, -1 are the coordinates of that point. And again, because it is a quadrant 4 situation, we use the negative angle. So that angle is negative pi over 2. It's 90 degrees down, or pi over 2 units backwards from 0. So it is negative pi over 2. In this case, the leg length and the hypotenuse radius are both 1, so it has to be on an axis. Let's look at 4. Cosine inverse of 0 will be equal to something. That 0 inside an inverse function is a ratio. So the answer we're finding will be an angle measure. Cosine inverse could be in quadrant 1 or 2 for the principal value. Being zero as a ratio, we are on an axis. So we may not be in quadrant 1 or quadrant 2. But 0 is neither positive nor negative, so we can't really say if that's in quadrant 1 or quadrant 2. So if we look at our coordinate plane, cosine is x. That x would equal 0. So where x equals 0 in either quadrant 1 or 2 or between would be straight up. The x value is 0. We do not move side to side, so we move straight up. That coordinate would be that coordinate would be 0, 1, straight up. Okay, we do not move side to side. That's the x equaling 0. It's 1. That is an angle of pi over 2. So cosine inverse of 0 is pi over 2. Now, let's look at 5. We are finding the exact value of these expressions using radians and radicals as needed. So, when we have these equations, these functions within a function, there are 2 parts. We work the inside function first. So, here, we're going to find cosine inverse of 1. And we're going to get an answer. Okay, that 1 being inside an inverse is a ratio. So we're going to find the angle that accomplishes that, and then we will find cotangent of that angle in the second step. So right now, let's work on cosine inverse of 1. Cosine inverse could be in quadrant 1 or 2. It's a 1, so we might be on an axis. It is positive, so we're leaning towards quadrant 1 here. So if we draw this out, remember cosine is x, so that x is 1. So in quadrant 1 or 2, the only place that x could be 1 is straight out. We go out across 1, up 0, and that is at 0 degrees or 0 radians. So cosine inverse of 1 is 0, and that is an angle. Now, we do the second part of this. Now we do cotangent of 0 will equal something. That 0 being inside a regular trig function is an angle, so we're looking for its ratio. Cotangent is x over y. Well, here's our x, here's our y, so that is 1 over 0. 1 over 0 doesn't exist. I'll put this here. That is undefined. 1 over 0 is undefined. So this final answer here is undefined. We haven't seen a whole lot of those lately, but they can happen. 1 over 0 is undefined. All right, let's look at 6. We have secant inverse of secant of pi over 6. So we'll do this inside piece first. Secant of pi over 6. And we'll get an answer. Secant being a regular trig function, that pi over 6 is an angle. So we are looking for the ratio. Plotting pi over 6, it's going to be in quadrant 1. Pi over 6 would be here, perpendicular to the x-axis, one leg on the x-axis, theta at the vertex at 0, 0. Now, the reference angle here being pi over 6 is 30 degrees. It's a 30, 60, 90 triangle. So across from the 30-degree angle, we label 1/2. Across from the other angle would be square root 3 over 2. That hypotenuse is 1. So we're looking for the ratio for secant. Secant is 1 over x. So that would be 1 over square root 3 over 2. Remember, 1 over a fraction flips it. So that's 2 over square root 3. We don't leave it that way. We need to fix the roots. Root 3 over 3. And that will give us 2 root 3 over 3 for secant of pi over 6. Now, the second part of this is to do secant of that result. So we'll do secant of 2 root 3 over 3 equal to something. That 2 root 3 over 3 is a ratio. Our final answer here will be an angle. Now, secant of 2 root 3 over 3, that came from 1 over square root 3 over 2. So think of this as secant of 1 over square root 3 over 2. Okay, so what that lets us do is secant is 1 over x, which is 1 over root 3 over 2, meaning that x is root 3 over 2. Now, where x is root 3 over 2, we actually already have that triangle. Secant inverse, I labeled that wrong on all of them. Secant inverse of this can be of a positive ratio will be in quadrant 1, so we are in the right quadrant. This is the same angle we started with. This is pi over 6. Now, if you look at what goes on, secant inverse and secant undo each other. The only thing we have to make sure of is that we are in a principal value quadrant. And since that is an angle in quadrant 1, that is the principal value quadrant. So secant inverse of secant of an angle in quadrant 1 is itself. Let's look at 7. Cosecant of tangent inverse of -1. We'll do the interior. We'll do the inside first. So tangent inverse of -1 will equal an answer. That -1 being inside and inverse is a ratio. So that answer will be an angle. If we look at tangent inverse, it can be in quadrant 1 or 4. With a negative ratio, this will be quadrant 4. So as we draw this, tangent is y over x being -1 over 1, meaning our legs here are congruent. So again, that gives us a 45, 45, 90 triangle in quadrant 4. So draw the angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at the vertex at 0, 0. With these legs being the same, it's a 45, 45, 90 triangle. That reference angle would be 45 degrees or pi over 4 radians. We are in quadrant 4, so we need to use the negative angle. So we will call this angle negative pi over 4. It's pi over 4 down from the x-axis, making it negative pi over 4. Now, the second part of this, we need to do cosecant of negative pi over 4. That will equal a result. That negative pi over 4 is an angle. That result will be a ratio. Cosecant is 1 over y. We already have that triangle drawn. Being a 45, 45, 90 triangle, the legs are root 2 over 2. The y is negative because we are in quadrant 4. Hypotenuse is 1. So 1 over y would be 1 over root 2 over 2. 1 over a fraction just flips it. So that's 2 over square root 2. Can't leave that root in the bottom, so we multiply by root 2 over itself. And this gives us 2 root 2 on top over a 2 on bottom. These y's are negative, so that negative sign still stays with us. These 2's divide out, leaving us the negative sign and square root 2. So cosecant of negative pi over 4 is negative square root 2, and that is our final answer. Now, let's look at number 8, sine inverse of cosine of 2 pi over 3. We need cosine of 2 pi over 3. That will equal a value. 2 pi over 3, if we draw that on the axis, On the right is 0. On the left is pi, or 3 pi over 3. So the top would be 1.5 pi over 3. That makes 2 pi over 3 in quadrant 2. Draw the angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at 0, 0. This 2 pi over 3 is an angle, so cosine of it will be a ratio with that reference angle being pi over 3. That is 60 degrees. So across from a 60-degree angle is root 3 over 2. The other leg would be negative 1/2, negative because it's on the left, hypotenuse of 1. Cosine is the x. Cosine is x, which is negative 1/2. So cosine of 2 pi over 3 is negative 1/2. That's our ratio. Now, we need to do the outer part. We need to do sine inverse of negative 1/2. That will be equal to a value. That negative 1/2 is the ratio we got for the first part. So its answer will be an angle. Sine inverse can be in quadrant 1 or 4. This being a negative ratio, we will be in quadrant 4. I'm going to draw just quadrant 4 here. So we will draw that angle into quadrant 4, perpendicular to the x-axis, one leg on the x-axis, theta at the vertex at 0, 0. Now, sine is y. Sine is y, so our y would be negative 1/2. So that y leg is negative 1/2. That makes the x root 3 over 2, hypotenuse always 1. So across from a 1/2, that reference angle would be 30 degrees. In radians, that would be pi over 6. Now, again, we are in quadrant 4, so we use the negative angle. We start at 0 and rotate downwards. Negative pi over 6, that's clockwise. So our final answer here is negative pi over 6. All right, guys, that is it for this first review video. Second part coming soon. Bye, y'all. See you in just a minute.